Hi, I'm Kim, and I'm from Project 20. Our project was to make a smartphone blood glucose meter. The purpose of our project is to create a device that will provide easy access to measurement data. We also wanted primary care providers to be able to monitor the blood glucose levels. That way, patients can email the data to their doctor, or teenagers can email the data to their parents. Then they wanted to have a smartphone be able to send reminders to the user that they need to take a blood glucose test. Finally, we wanted to have the blood glucose device be able to be easily integrated into a smartphone case. This is a summary of our project. The blood glucose meter we created takes tests that fit within industry standards. The device is fully operated by the smartphone. The smartphone communicates with the device wirelessly by using Bluetooth. The smartphone is also able to send emails of the blood glucose measurement data. This is our block diagram. We have the microcontroller being powered by the battery and the power supply circuit. Then there's the test measurement circuit, which takes the blood glucose measurements. The data is sent from the microcontroller from the Bluetooth module to the smartphone, and that's where the results are displayed.
Hi, my name is Tyler, and I will be talking about the measurement circuit and our test setup. For our test, first a test strip is inserted into the device. Then a small amount of blood is added to the test strip. Finally, using cyclic voltammetry, we apply a voltage to the test strip and are able to determine how much glucose is in the blood. I will now talk about the chemistry which allows for the blood glucose measurements. We use the fact that the reaction between glucose and gluconic acid is a reversible reduction-oxidation reaction. An enzyme present in the test strip causes this redox reaction. That redox reaction releases two free electrons. Those two free electrons are then transferred to mediator chemicals, which can allow the further transfer of those electrons to the electrodes in the test strip. We then are able to measure the change in current based on the transfer of these electrons. There are a number of methods to use electrochemistry to measure blood glucose levels in blood. We chose to use cyclic voltammetry. This method applies an alternating triangle wave to the electrodes, and then we are able to measure the difference between the currents on the electrodes to estimate the amount of glucose in the blood. This is our measurement circuit. We use a TLV5636 digital to analog converter. The digital to analog converter takes the information from the microcontroller and transfers that into our actual triangle wave test signal. That test signal is then applied to two op-amps, which then amplify the test signal to the test strip electrodes. The test strip electrodes then react with the blood, causing a change in current, and the op-amps measure that change in current. Then that information is sent back to the analog-digital converter of the microcontroller.
Now I'm going to talk about the microcontroller. We use the MSP430, and we chose this design because it works well with a Bluetooth solution that we found. It has a low voltage range and has an on-chip analog to digital converter. The low-level code that we use to program the microcontroller with, we coded in C on IR Workbench. The functions of it is to receive signal from Bluetooth module, then it starts the measurement circuit test, it receives the measurement data, and it sends the data back through the Bluetooth to the smartphone. Now I'm going to talk about the Bluetooth module. We used a single chip solution from TI. It's easily incorporated with the microcontroller that we chose. It's the smallest Bluetooth solution in the industry, has very low power. It also has a sleep mode, which helps our power management. The smartphone we used was the Samsung Galaxy S Captivate. It has an Android operating system. It uses Bluetooth for connectability.
Hi, my name is Heba, and I'm going to talk to you about the high-level code for our project. We coded our project using Java for Android operating system. And we had our application starting with opening the blood glucose level menu, and it has three options in it. The first one is taking the blood measurement, and the second one is storing the data, and you can take a look at the history for the previous data you took, and the last one for sending the data through email. Also, the application provides an alert for the user and reminded him or her of the next measurement. I'm going to talk to you about the power management slides now. We have this schematic for our power management, and we had it designed to supply 3.3 volts and a current of 250 milliamps as an output for our microcontroller and the rest of the device. And we used the dropout regulator chip called TPS 77310. For our improvements, we were planning to make our device smaller as possible, and that will make it easier to fit the smartphone and easier to carry. So we PCB all our circuits together, and we also added LED indicator lights. And this is the PCB schematic for our design, and it's including the microcontroller and the other circuits all together in one board. And this is the layout for the PCB schematic. So our advice for next year for senior design, try to make your requirement in the first term 100% achievable. Also spend a lot of time working on them. Do not have like a requirement depending on the other, or if you could. So if one of them fail, you don't have to fail all of them. Also, when you finish your design, order your parts as soon as you can, and order many of them, so you have like a time, or you have extra parts if one of them broke, or you have to redo the test more than one time.
This is our final device. Some things that separate our device over other blood glucose meters is it is allowed connectivity to a smartphone. That connectivity is done through Bluetooth, and the final device, our blood glucose meter, is located underneath the smartphone in a protective case. So now I will demo the software and our measurement circuitry. We have in the software three options. First option is to take a blood glucose measurement. Second option is to view previous history, measurement history, and the third option is to send all that previous measurement history to a email account. Now I will take a blood glucose measurement. First I need to turn on the device, connect to it via Bluetooth. Set the password. Now I can draw some blood. There we go. And take a blood glucose measurement. We can see there that I have a blood glucose of 117 milligrams per deciliter. We can review all the previous data, and then we can also send that to my email account. We can see that once the email is sent, get a notification that it's arrived in my email. See, now it's in plain text format, and we can do what we want with that data. Also, our application notifies the user that another blood glucose measurement needs to be taken at a certain time, and that is our final device.